So thank you for that lovely introduction. And for those of you who were around for the talk earlier, thank you for sticking through what I know can be a heavy talk and a difficult one. The good news is this one is going to be a little bit less preachy and more designed to make your engineers happier is really the goal of this. So I'm Emily Gorcenski. I'm the head of data at ThoughtWorks Germany. By way of a brief introduction of the company, ThoughtWorks is a global consultancy. We have offices in, I believe, 14 countries now around the world, 45 cities, and almost at this point, 8,000 technologists. And I bring this up not because I'm trying to sell ThoughtWorks, although you're certainly free to get in touch with me if you want our services, but really because we have seen problems of all different sorts at companies of all different sizes in all different industries. And this talk today is going to be about some of the patterns that I see over and over, regardless or independent of those variables. Also, one of the things that we like to do at ThoughtWorks is share our knowledge. We write quite often. Some of the sort of seminal concepts in modern software delivery, like continuous delivery and infrastructure as code, have come in books that were written by current or former ThoughtWorkers. And one of the publications that we talk about is or that we produce twice a year is the ThoughtWorks Technology Radar. And increasingly, we're starting to see more and more topics surfacing on the technology radar that have to do with engineering data, data systems, data products, data platforms in ways that are more sustainable than what we've done in the past. So let's talk about these patterns that I see all over the place. The reality is that data engineers are actually hurting in a lot of organizations. Retention is difficult, and it is very hard to recruit data engineers and data scientists at the current moment. The job market very much favors the candidate and not the company. And so we should be incentivized to make the lives better of our data professionals. So the first pattern that I see is the sort of quote unquote firefighting issue. Too often in organizations, data engineers are spending their time putting out fires. This means that they're dealing with things like backfills or database issues, reports that are late or missing. And what this means is that they're always they're in a purely reactive mode. They're always responding to some incident rather than engineering systems for higher reliability. On the other side of that coin, so we had fire and now we have ice, is a different but related pattern that I see at organizations often, which is data engineers are treated as ad hoc. They're spending all of their time doing ad hoc requests. They're basically being treated like an IT help desk. I like to describe this as building a snowman one snowflake at a time. You know, oh, can you pull me the data on this? Can you pull me the data on that? As if that data exists in some nice, clean, and perfectly maintained table somewhere, just waiting for somebody to query it for the wealth of insights. That's not reality. That's not what's happening. The third pattern that I see in data in organizations as it pertains to data engineering is long delivery cycles. Some of you might recognize the tower at Berlin Airport, which I'm pleased to announce is opening this fall. I believe the year is now 2012. But we see this in data engineering all the time. We want to implement, say, a Kubernetes migration or increase the version of a database or implement a Kafka stream. This ends up taking much longer than it should. And the reason that these lead times are so long is because of the first two issues. Data engineers are not given enough time to engineer systems. And then finally, the biggest problem that I see at organizations is a lack of trust in the data. And this lack of trust is coming from poor data quality. This is the number one anti-pattern that I see, regardless of company. And this is the most dangerous anti-pattern, because when people start losing trust in data, then what happens is they stop making data-driven decisions and they start using their instinct to make decisions instead of doing what the data is telling them. That is the opposite direction of where we want to be going if we're trying to become a data-driven organization. So if any of these patterns sound familiar to you, there's great news. You are not alone. And it is not a feature of some unique property of your team, your organization, or your industry. I have seen these patterns happen in organizations from 100 people to 100,000 people. I've seen them in every industry, from real estate to e-commerce to medical devices. No matter what you do, data is kind of a mess right now. We can do better. So in order to think of how we can do better, let's think of how we've done better in the past. So when I started looking into how can we engineer better data systems, I started looking at the problems and I said, wait a second, all of these problems sound exactly the same as something that I've seen before. Where was it? Well, that was the operations world 10 years ago. In some places, it's still the operations world today. But Liz and I just gave a talk about site reliability engineering. And site reliability engineering evolved from this need to stop the bleeding in operations teams because people were being overworked and underappreciated. So how did we break these habits in the operations space with sort of quote unquote normal software delivery? And how can we take those learnings and translate them to the data space? So we've seen this problem, as I mentioned, in operations. The sleepless nights, the long on call, being paged in the middle of the night for something that you didn't break, but somehow it's now on you to fix. These are the sort of trends that we've seen over and over and over. We're seeing them in data engineering now too. So what is the first thing that we did? So in software, the first thing that we did was start to redefine our organizational structure. So we started moving away from hierarchies and we started moving towards domains. We started bounding context. This happened with the advent of microservices and other organizational and architectural transformations where we can look and say, this is what the product is, this is the scope of the product, this is who's responsible for the product. Now let's focus on just building that product rather than how do I integrate this product into this complex architecture or this complex ecosystem that takes me 3 months to deploy software into. The other thing that we did was build up concepts like DevOps and site reliability engineering. So this is all part of sort of the continuous delivery transformation, the agile taking over the world and things like that. But with DevOps, what we did was we said, okay, now that we've bounded the context of our products, now we're going to start reshaping the expectations of our engineers. And so sometimes companies were like, yes, DevOps, I have a DevOps team. That's not how you do DevOps. DevOps is not a team. DevOps is when developers are responsible for production deployments. That means that developers are responsible for production incidents. That also means that developers are responsible for the quality of their production software. This was a small but significant change in the way that software was being developed. Because what this did was, once people started becoming responsible for the issues that could arise, they started feeling a little bit of the pain of when issues arise. And so we started building better tools, better practices, and implementing better patterns of software engineering to stop making it hurt so bad. One subset of this was site reliability engineering. This kind of grew up independently. It's a little bit disingenuous to say that SRE is a subset of DevOps, but the Google SRE book says that it's a subset of DevOps and they invented the concept. So I'm going to go with it. SRE is a sort of a specialization of DevOps built around keeping enterprise class, carrier class systems online with high reliability, however we define that reliability to be. And that is the essence of what this talk is now going to be about. So the sort of evolution of SRE came with the concept of building out service level theory. So we have SLIs, SLAs, and SLOs. We're going to talk a little bit about these now, kind of introduce the concept very broadly. But really, I want to talk about SLOs as the most important thing in this sort of stack of terminology. So what are these service level things? We have indicators or SLIs, objectives or SLOs, and agreements or SLAs. And these are all built around one concept, and that is codifying delivery promises in a way that is measurable and traceable. This is the most important thing. So it's not just, oh, I want my service to be up 100% of the time, 24/7. That's not a realistic goal. SLOs are about defining targets and measurements that make sense in a way that is unambiguous and can be tracked. At the core, SLIs are the indicators or the things that you are tracking. And when we define SLIs, we want to not just talk about what are we measuring, but how and how frequently. What units is it in? Is it over a rolling window? Is it a percentile? Is it a quantile? What are the, how are we actually computing these indicators? Those are very important things to get right, because otherwise, if you don't have the specifics of your definition, then you get into a case where your service level is now open to interpretation, and that's not a place that we want to be in. We have SLOs, which we can roughly think of targets for our service levels. I like to instead think of SLOs as the North Star for a team. SLOs should be the benchmark by which we measure our engineering effort. So we want to meet them and we want to surpass them, but we also want to think of them in a structured way that they drive continuous improvement. I'll talk about that briefly in a moment. And finally, we have service level agreements. Service level agreements are essentially a contract built around an SLO, or one or more SLOs, I should say. These are bipartisan, right? These are between two parties. And they talk about what are the commitments, what are the promises that I am making in providing the service, and what are the promises that you're making to me in exchange for the service. So that might be money if you're a cloud provider. It might be submitting bug reports in a certain way if you're just doing internal team service. It might be expectations around time to respond to tickets before an escalation, right? So that somebody is not running to the manager if you haven't fixed their bug within the first 4 hours of your morning. One of the things that I see, and this is a little caution, is that in lots of organizations, people get SLAs and SLOs wrong, or they get them mixed up. These are two different things. If you define an SLA just in terms of an SLO and not around what type of work needs to go in to meeting and maintaining it, then you're sort of missing the point of what service level theory is all about. And I'll talk a little bit about that now. But I see this all the time where people are like, my SLA is 99% uptime. It's like, no, that's your SLO. Your SLA is what's going to happen if you don't have 99% uptime. Your SLA is what's going to happen when we need to do an upgrade and we can't meet 99% uptime because we have to take the system down in order to apply a security patch or something like that. So when we talk about building effective SLOs, this is true for software as it is for data. These are product decisions. These are not things that emerge from a system. These are things that drive forward the engineering quality of the system. And the tighter that your product requirements are, the more engineering effort you have to put in. I see a pattern all the time where people will build, say, a machine learning algorithm that needs to do, classification of something on a web service, and they're like, all right, I built my system. Now I'm gonna define my SLOs. No, that's backwards. You want to define the SLOs around what your product needs. This algorithm must be effective 99.9% of the time. Otherwise, bad things happen. When we frame them in terms of product decisions, then we should be able to make clear that these map to business value. And so what we want to do is we want to define SLOs that are clearly linked to some amount of money, something that is valuable to us as a business. We don't want to just pick SLOs because that's what Google does, or that's what Amazon does, or that's what Microsoft does, or whatever. We want to pick SLOs that make sense for our product. And our SLOs in one team may not even be the same ones as the SLOs in another team sitting down the hallway. Because the value propositions are not necessarily going to be the same. Also, a lot of organizations use SLOs to drive incident response, and I think this is bad because SLOs should be carrots and not sticks. They should be a tool by which we can improve our service, and they should not be a driver for punishment. They should not be punitive. They shouldn't be used to, say, withhold budget for an underperforming team. They should instead be used to give budget to a team that is able to elevate its service level to a higher standard in the next quarter, in the next year, in the next whatever. They should be driving the quality of our product forward. They should not be punishing us when things that are usually outside of our control have a product quality impact. So we want to think of SLOs as a positive thing. And because they're a positive thing and they're meant to drive change, SLOs themselves should change. They should evolve over time as we get better at building technology. So if one time your latency is 100 milliseconds, maybe we can step that up to 70 milliseconds. Or if your availability is 99%, maybe next year we target 99.9%. These are the ways we need to revisit them. And these are the ways that we use SLOs to keep our teams getting better and better and better over time. So that's a lot of introductory material. So now I want to actually talk about this in a concrete data engineering context. So let's talk about them for data engineering. This is just one example. If you want to read more about SLO theory, I'm going to pitch a book. It's not mine. It's this book by Alex Hidalgo. He does talk about data in one chapter of this book, but lots of really great stuff about how to implement it. I'm not paid to advertise his book. I just think it's really awesome and that he's really awesome. So the first challenge is that SLO theory came from the cloud, and not all of these concepts translate super easily to the data space. There's a lot of really advanced work around latency measurements and how to build the right SLO around uptime. Some of this isn't relevant for data. If you're building a BI system and you know that your query is going to take 2 to 3 minutes because you're crunching on so much data, 40 milliseconds versus 50 milliseconds isn't going to be very meaningful. So we actually need to develop new theories specific for the data context. Some ways to do that, you can think of these in terms of value axes based on what your data product is. If you're doing online machine learning, sure, latency is probably super important, but so also might be precision and recall, or maybe your false negatives are way more expensive than your false positives. And so we want to link it to what that value proposition is. Alternatively, if you're doing something like stream processing for anomaly detection, you could create an SLO around the time to detect an anomaly. So you want to minimize that time so that you're able to respond faster. So maybe you can build some statistics around that and use that as a service level offering. So when we define these in context of data, we have to ask what is the product and who is the product owner? In other words, who is the boss? Data engineering in an operations context like this makes this difficult. Because if you're doing something like a BI system, do you really have a clear product owner? The answer should actually be yes, because you have clear users. And one of the first things that I advise organizations to do is to make a clear product owner for that data platform, regardless of what it is, and to make sure that that product owner is talking to the users to get their feedback. Secondly, you have to build SLOs that make sense. I said this before, I'll say it again. 100% is impossible. Everyone wants 100% uptime 24/7, but I'm sorry, the power grid is not at that level of reliability. And so you have things that are going to affect that, your ability to deliver on that. And the more nines you add, the more expensive things get. And it's not linear. So if you go from 99% to 99.9%, that increase in cost is much smaller than the increase in cost from 99.9 to 99.99. So you have to ask yourself, what do I actually really need? What is worth the investment? Wayne Gretzky was the great one, and he only had 2 nines. So do you really need 99.99%? So here's a working example. I have a few minutes to go through it. So let's say that our use case is this. Let's say that I'm a supply-side business intelligence analyst, and I want the weekly sales reports to be available in time for my Monday morning planning meeting, which happens at 10 a.m. And I need to review these. So I really want the reports, the data ready by 8 a.m. so that when I go into this meeting on Monday morning, I have everything I need and we can submit our materials purchase orders before our competition. And that means that we will get more competitive rates. Okay, wonderful use case, clear business value proposition. Data is there faster equals less money spent. Great. So let's build an SLO for this. Let's say that we need to crunch this data overnight. We're going to crunch, a week's worth of data or 3 months worth of data. It must be ready by the time the analysts get in the morning on Monday. So how do we do this? So here's one sort of naive example. So you might say, my SLI is that data is fresh at 8 a.m., true or false, and the SLO is that the data must be fresh at 8 a.m. on every working day. Is this good? What do you think? No, this is not a good SLO. This isn't a bad SLO because binary measures don't give us a way to measure improvement very easily. Moreover, this sort of every working day is always an instantaneous measure and we don't care about history, right? And there's no way of telling like what's worse. What if the data is available at 8:02 in the morning? That's like a violation according to this SLO, but is that better? Is that not better than if the data is only available at 3 in the afternoon? Like what is bad? What is, are there degrees of bad? So let's think about ways that we could do this. So in Alex's book, he gives an example of, oh, maybe you want to do 99% of the data, must be available. Unfortunately, batch processing systems don't often work like that. We don't have the ability to go back and say, I'm going to only pick 99% of my data, and therefore it'll be a little bit faster. It's usually an all or nothing thing. So that's our central challenge. So let's think about it in terms of use cases. So the business intelligence analyst, maybe they want to really not just have the data available for this report, that's their key need, but they also want to look at it, during their working day, during the week. So let's say that we start measuring the data's lateness and we start accruing lateness at 8 in the morning and we stop accruing lateness at 6 p.m. And so any time by clock minute that the data is not fresh and up to date, like yesterday's data is not available within this time window, is bad and it starts accumulating over time. And we want 99.5% freshness over 30 working days. This is a much better example. Why? Because we can construct an error budget around this example. So if we do the math on this, this means that, with a 0.005% error budget, this roughly boils down to, or not roughly, exactly in this example, boils down to 90 minutes per 30-day rolling window. That means we have an hour and a half any given 30-day window where we can miss this if something bad happens. That means that, maybe we can actually do our database upgrade at 5:30 in the afternoon on Friday. Like maybe it's not a big deal. And, yeah, the system will be down, but, we're only eating up a third of our error budget at that point. So let's go ahead and do it. What does this get you? This gets you a lot of things. It gets you, if you craft an SLO like this, it's going to drive your team to supporting it. That means you're going to improve your pipeline observability. You're going to have better monitoring in it. You're going to implement better quality gates so that you're aware of data quality issues earlier on, which gives you more time to fix them or to react to them. You're going to have less technical debt built into your system. You can improve your documentation, reduce your bus factor, and you can automate much more of your tooling. All of this is built around this idea that you only have 90 minutes of time that you can miss. So if you know that you can only miss in that 90-minute window, what are you going to do to make that? And because this is an SLO, this is now your priority. So you're actually going to invest the time into doing this. And if somebody complains that, oh, it's 8:05, where's my data? Well, if you've only eaten up 5 minutes of error budget, you get to tell them, don't worry about it. So you can sort of forestall some of those complaints. So we actually put this into practice in one of my teams. I'll wrap up with this example. This is a little bit derived. Some things are changed to protect the innocent here, but we actually we had a similar use case, and we engineered our systems, a very complex system, with an SLO just like this. As we started doing this and tracking this, we got some immense improvements. Our total run duration of our pipeline was cut roughly in half. We implemented way more quality gates. We are now integrating, not only integrating, but we're automating the integration of data quality tests whenever we institute or implement or connect to a new data source. So we connect to a new data source and we automatically stand up data quality tests around it. This gives us the ability to stop the pipeline at different stages and investigate quality and make decisions on what to do if the data quality that day is bad. Because we turned this into an SLO and because we created working agreements around it, our support requests reduced by a factor of 3. And because of that, that meant we could spend more time engineering, which means that our lead time for features was cut in half. Our bus factor went down because because we built a better pipeline, there was less specific arcane knowledge in how to fix the pipeline. So now if we want to fix something, it's really just a couple clicks of a button and everyone on the team knows how to do it, which means that everyone is responsible and everyone can respond to these requests. So now our team is much more resilient. And because we cut down so much compute, we actually saved a bunch of money in the process as well. So this was actually a really interesting exercise for us. And this is just one example of one SLO that we could create. Alex gives lots of examples in his book around consistency examples, around other ways for fault tolerance and things like that. But we can really build some interesting systems if we start thinking in terms of deliberate, measurable, concrete service level theory for our data systems and our data pipelines. So that's all that I have. I don't have time for questions, but please feel free to reach out to me. My email is here. You can also reach me on Twitter at Emily Gorcenski. And so thank you very much.